Hi students, Miss DeLeo here. So today we are getting started on our second unit together. It is called linear modeling, and we are starting with section 3.1 in your book. So even though we are on our second unit, it is the third chapter in your textbook. So we're in section 3.1. And today we're going to learn a little bit about functions. All right. So before we get into what a function is, let's talk about a relation. A relation is something that pairs inputs with outputs. Okay? And a function is a special type of relation where every input can be paired with exactly one output. So this is kind of like the big idea that we're looking at right here. The big idea of this section is that every input can be paired with exactly one output. Okay, so maybe we might be thinking about what the heck is an input or an output? Well, here we go. We've got a normal coordinate like we have seen before with graphing. And we know the first element of that coordinate is an x and the second is a y. We have some other names for this x value, okay? And those are interchangeable, these three names. We can call x the input. We can call x the domain. Or we can call x the independent variable. All of these are characteristics and names for x. So all of these characteristics belong to x, and we could describe them this way or interchangeably. Y has some characteristics too. So y can be called the output, the range, or the dependent variable. And all of these are names or characteristics for y. So if we're talking about x and y, we can say x and y, or we can say the input and the output, or we can say the domain and the range, or we can say the independent variable and dependent variable. Whichever pair of words we use to describe a coordinate or describe x and y, we know these words means x and these words relate to y. So up here, when I say every input can be paired with exactly one output, what I mean is every x value can be paired with exactly one y value or output. And we're going to look at what that means. All right, let's get a little bit more vocab under our belt before we get going. So a domain is the set of all possible inputs. And remember, an input is an x value. Or dependent variable. Independent variable, sorry. I misspoke. Okay. And the range, which we kind of already seen these words above, but we're going to just go into it a little bit more, is the set of all possible outputs or y values. And these are the dependent variables. So for a function, what we're doing is we are working with something that is linear. And what we're saying is we can put in a value and get out a value. Put in a value, get out a value. And we can look at all of those potential values that we put into a function as an x value or input, and the result that we get out is an output or a y value, a range. So let's keep going here. Here's one way how you can identify a function, okay? And that is graphically using something called the vertical line test. So how this works is if you hold your pencil vertically, I'm going to use the highlighter function. If you hold your pencil vertically, you should be able to drag it across a graph along the x-axis and have it only intersect that graph at one point at all times. So for instance, right here, every time I draw a vertical line, or if I were to be able to move my pencil across this graph, I can see I'm always only intersecting the graph or the function at one point. So that would make this a function. Over here, I can see that at a couple points in time, and all it takes is just one for me to determine this is not a function. At a couple points in time, I draw a vertical line and I intersect the graph or the function or the potential function, the relation, at two places. That means this is not a function. And over here, I go look at each individual element, and if I had to draw a line through it, they only are being touched at one point at all times. So yes, this is a function. So this is one way that we can identify if something is a special type of relationship, which is a function, meaning every x value has only one y value. Over here, this is not a function, because this x value, for instance, has two y values, which makes it just a relation, not a function. Over here, every x value has one y value. So that's what we're looking for. Let's kind of continue that train of thought down here. Here's an example. We're going to find out if these things are in fact functions. So what we're going to do is we're going to list out our inputs and our outputs. So I'm going to list out my input and my output. Okay, and remember my input are all x values. So I'm going to go through, and for my input, I'm going to have a -2, -1, 0, 1, and 2. So I'm going to list those: -2, -1, 0, 1, and 2. And for my output, I'm going to list those, and they are 2, 2, 2, 0, 0. I do not need to repeat numbers when doing this. So I'm going to have 0 and 2 as my potential outputs. And what I want to see is if every x value has one unique y value. So we're going to check. For this first coordinate, I input a -2 and I output a 2. For my second coordinate, I can see I input -1 and I output 2. Input -1, output 2. Input 0, output 2. Input 0, output goes to 2. Input 1, output of 0. Input 1, output of 0. And input 2, output of 0. Input 2, output of 0. So what I'm looking at is over here, does every x value only go to one y value? And the answer is yes. So is this a function? Yes, it is a function. Every x value has only one y value. Let's take a look at this next example. We're going to list again our inputs and our outputs to help us determine if this is a function. Okay, inputs, I've got -5, 0, 5, and 5, because remember, input values are x values. I don't need to put repeats, so -5, 0, and 5. So there are my x values, or my inputs. And my second values are going to be my outputs, which are, 0, 0, 0, and 10. So I don't need to worry about repeats, so I have 0 and 10 as my outputs. And now I'm going to read the coordinates like I did before. Input -5 and output 0. Input 0, output 0. Input 5, output 0. Input 5, output 10. And here is where we get a problem right here. I was expecting an input of 5 and output of 0. I got that first. And then I get 5 again, and I'm expecting that every x value has only one y value. So I'm expecting if I see the x value 5, I'm going to get an output of 0. But I see the x value of 5 again, and I get a different output of 10. That is not a function. Every x value can only have one unique y value, and this x value has two y values. Therefore, it is not a function. So this would not be a function. This x value has two y values. And we cannot have that. In order for something to be a function, every input needs to have exactly one output. This is so important that we are even going to write this loud and proud at the very bottom of our paper, okay? So for something to be a function, so for a function, this is something we're going to say to you over and over and over again. Every x value has only one and only one unique y value. Every function has only one unique y value, okay? So over here, every x value only had one y value, and over here, every x value did not have only one y value. This had two. We don't care if the y values share x's. We don't care this direction. We only care x output, input to output. Okay? Let's keep going. Find the domain and range of the graph. Is the relation a function? Okay, so let's do this. We are going to list out our domain and range. So I'm going to say domain and range first. That's what it tells me to do, to find the domain and range. All right, so my domain are all x values. So I'm going to come over here and look at, for this point, what is my x value? It's -2. And for this point, what is my x value? It's -1. And for this point, what's my x value? It's 0. And this point, my x value is 1. And this point, my x value is 2. There's all my domains. Now I'm going to look for my ranges. For this point, my y value, sorry, because we're talking about range is y values, are 4. This point, my y value is 2. And this point, my y value is 0. Now, I don't need to repeat domain and range values because we're saying these are possible range values, and they are. So over here, I've got 4 again, and I've got 2 again, and 0 again. So I'm not going to relist them. Okay, is the relation a function? So remember that vertical line test. If at any point I can draw a vertical line through any value and it intersect the x-axis more than, or intersect the relation more than one time, it is not a function. But in this case, it is a function. So we can say yes, it is a function. And how do we know? It passes the vertical line test. So we're going to learn a little bit about this later on, but if you notice, there are some differences between graph 3, graph number 3, and graph number 4, okay? And the differences between graph 3 and 4 is that you can see we have a bunch of little individual dots here, and over here we have an entire line, okay? When we have a graph with an entire line, you guys will be asked to list out every single value. Well, we know that there are infinitely many values between 1 and 2, and infinitely many values between 2 and 3, because we could have a decimal place that goes on and on and on forever. So there's really no way for us to list all of these in between values without using a certain type of notation. This is some notation that you're going to have to get used to. We're always going to have a lower bound, less than or equal to x, less than or equal to an upper bound, and a lower bound, less than or equal to y, less than or equal to an upper bound. So what we're saying is that for these x values, the function is between, that's kind of what this says, is between, has a domain between 1 and 5. And this notation lets me know that it's not just 1, 2, 3, 4, and 5, but every single value in between 1 and 5, including all decimals, everything, all inclusive. So if you see little dots, you're going to list them out. If you see a smooth line or a smooth curve, we're going to use this notation every time. And don't worry, we're going to do it so much that you guys will be pros by the time your test comes. But if we see a smooth line, we're going to use this kind of notation that lets us know not just the lower bound and the upper bound, but every single number in between all decimals. So let's look at the y values. The y values, I can look this way, and the furthest up this graph goes is 4, and the lowest it goes is 0. So I can say that this graph goes from 0 to 4. I've got my lower bound and my upper bound. I do not go beyond that. The graph does not go any further. So there is some new notation for you that we're going to get used to, but don't be afraid. Is the relation a function? If I were to hold my pencil up and drag it across vertically, would it hit the graph at 2 points at any time? And the answer is no. Therefore, yes, it is a function. It passes the vertical line test. Alrighty, almost done. So up until until this point, we have only seen functions as visual representations on a graph. A little bit later on this week, we're going to learn all the different ways to identify a function. But right now, we're kind of just giving you a preview. This tells you that this is the function, the function. And it's right here. This is a way to represent a function using an equation, okay? Without the graph, just an equation, which you guys have worked with before. So there is the function, and it represents the number A of avocados you have after making B batches of guacamole. Identify the independent and dependent variables. Remember the independent variable being your x value and your dependent variable being your y value. Well, based off of what we already know for independent and dependent variables, let's talk about this. Your independent variable is what you put into the equation. And for this variable, that is going to be, any guesses? Oops, I didn't mean to dot the E. Any guesses? It's going to be your B. So your independent variable in this case is just x in disguise. It's x in context, and this time it's B, and it's the batches of guacamole. And your y variable is going to be the output or the result. And after we input B, we're going to get an output result. And that result is going to be A. So your independent variable, or your dependent variable, is y in disguise as A in context, which is the number of avocados you have left. Okay, so now we're going to move on to part B, and it's asking me to identify the domain and range. Well, above, I was just able to directly look at the graph and find the domain and range, but now I don't have a graph. Now I have an equation. So how am I going to get the domain and range? Well, remember, the domain is known as the input. So literally what that means is I can input each of these values into this function and get an output. So we're going to do that. Let's see. If I have an input of B equaling 0, then that means I can input it in for B, -4 times, instead of B, I'm going to put 0 plus 14. And I would get that A equals 14. So while my domain is already listed here for me, now I've got one value for my range, 14. Well, I've got a couple more to find. I did this one, and now I'm going to keep going. What if B equals 1? Let me input it into my function, -4 times 1 plus 14. -4 plus 14, well, A equals 10. So now I have another output. So what our range is depends on what our domain is, which is why y is the dependent variable, x is the independent variable. We input these values to get a specific output, one unique output. All right, let's look at this. If B equals 2, because we've done 1, now 2. A equals -4 times 2 plus 14. -8 plus 14. A equals 6. So I can add that to my list of range values. And the last one is that, what if B equals 3? A equals -4 times 3 plus 14. -12 plus 14. A is 2. Awesome. So for my domain of 0, 1, 2, and 3, I have my range. Let's very quickly interpret these. What does this mean in context? If b equals 0 and a equals 14, what does that mean to me? B is the batches of guacamole and A is the number of avocados left. Well, then this means if I make 0 batches of guacamole, then I will have 14 avocados left. Because I didn't use any, right? And down here, we can interpret this one too. Well, if I make 2 batches of guacamole, I will have 6 avocados left. So we can start to see some patterns because this is linear. We can see how much we decrease each time. So you can discuss with your classmates after this, how many avocados does it take to make 1 batch of guacamole? And so these are things we're going to be working on in the next unit, and the next time I see you guys in class, we're going to go over some practice problems together. But the main things you need to take away from today is that in order for something to be a function, a special type of relation, every x value needs to have one unique y value. We can check that a couple ways, graphically or using an equation. Doesn't matter. We've learned some new notation today. If we have a solid line, we need to use this special notation to include all decimals. But if we have individual points, we can list out the x and the y values without repeats. So remember, if there's one thing you're going to bring to class next time, it's that if something is a function, every x value has one unique y value. Okay, you guys, so proud of you for hanging in there with these notes, and we'll see you in class next time we see you to go over some practice problems.